Okay, I'm making this video in response to a LinkedIn group member's question. Okay, and so on my Math Card Magic LinkedIn group, I have a group member who asked a question about a card effect that claims that it's unexplainable. It cannot be explained. Okay, so let's go down to the video. And then we'll just play the performance portion of it, and then we'll talk about the video. Okay, so here is the post. So Mary writes, here is a supposedly unexplainable card effect, which has gotten over 1 million views in the first 2 weeks after it was published. The performer claims, quote, "This trick cannot be explained." And then she goes on to say, I doubt that, but I don't think I fully understand what's driving this effect. Can any of you in our LinkedIn group explain simply and clearly why this card effect works? And then I replied to Mary, thank you, Mary, for your post and question. I want to give our group members some time to respond if they would like to before I chime in. And so that was over a week ago. And no one has responded yet. So this is the video we'll look at, and then we'll talk about the mathematics behind it and actually explain what's going on with it.
This is the unexplainable card trick, and honestly, this trick freaks people out. So this is all about intuition. You ask the spectator, I want you to cut and use your intuition to see if you can cut exactly half of the deck, which they do so. The magician then counts them onto the table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28. So not quite half, but you were using your intuition and you almost got there. The magician then explains to the spectator that he now wants him to shuffle these two piles together, which the spectator does. So once they are shuffled, the magician takes them back and deals 2 even piles of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the spectator can choose either this pile here or this one. It's entirely up to them. So let's say they choose this one. The magician then shows his card and says, look, you shuffle these any which way you liked. Actually, you shuffled the entire pack. Now I'm going to use my intuition and tell you exactly what these cards are, whether they're red or black. I'm going to use my intuition and tell you the first card is a black card, which it is. The second one is a red card. The next one is black. The next one is also black. My intuition tells me the next one is also black. The next one is red this time. The next one is black. The next one is black. The next one is red. And the last card, not only is it red, but it's the 10 of hearts. And that's a real miracle, freaks people out, and I'm going to show you exactly how it's done right now. Yo, what's cracking, everybody? Welcome back to the channel. So this is the tutorial for the trick that cannot be explained. And seriously, this freaks people out. And although I'm going to teach you the method can't even be explained. I will explain in a second. You'll see why. So it uses a principle called the Gilbreth method. And honestly, it's insane.
Okay, I don't know if any of you noticed the organizational structure of the deck when he had the cards face up and he was counting out how many cards were cut by the spectator. But it was clearly set up in an alternating pattern of red, black, red, black. Okay, so it's a cyclic packet. And so because of that, the Gilbreth principle can be employed if you perform a Gilbreth shuffle, okay? So if you watch the whole video, he actually does explain everything that he does so that you can actually perform this for yourself. The only thing that he leaves open is his statement that the Gilbreth, he calls it the Gilbreth method, which is not how it's described. It's the Gilbreth principle. He says it's something that cannot be explained. Well, the reality is mathematicians have rigorously proven why the Gilbreth principle is true. And in particular, for an alternating packet, we're actually using what's called the first Gilbreth principle. That is the first principle that Norman Gilbreth discovered when he was working with alternating decks of red and black cards. Okay, but since then, rigorous proofs have been provided that completely explain and justify the outcome of a Gilbreth shuffle when performed on a cyclic arrangement of a deck of cards, or any objects, actually. Okay, so I guess I want to point that out. The Gilbreth principle is very well understood and has a solid mathematical justification that completely dispels any mystery as to what's going on and what the outcome will be for any Gilbreth shuffle. Okay, so let's just take a minute to kind of develop our intuition for what's called the first Gilbreth principle. Okay, so what Norman Gilbreth discovered is that if you have an alternating deck of red and black cards, so here it'll be red and blue magnets, and then if you deal any number of cards into a second pile from the top, any number whatsoever, which, by the way, it reverses the order of these cards, right? They're being reversed as we deal them to the table. And then you interlace them by way of a riffle shuffle. The resulting arrangement will consist of pairs of cards, when taken from the top, will consist of one red and one black in some order. And that's what drives the entire effect that we just saw. Okay, so I've reverse counted, we call it, just 8 cards here. Imagine these as cards. Okay, so a riffle shuffle has a very important property, namely the cards in one pile, like this pile here, they will maintain their relative order, meaning this card here, if it's a riffle shuffle, will never go above that one. Okay, the only way to do that is to like drop the cards everywhere. Okay, so as these interlace in some random fashion, we just need to remember that the order of these cards relative to each other will be maintained. The order of the newly dealt out pile of cards relative to each other will also be maintained. So if you look at what's happening here, what can the top card be? You know, as these come together in some way, interlace in some way, well, there's just 2 possibilities. The very top card could be red, right? Or it could be blue, the very top card, right? Maybe that one gets shuffled to the top, okay? Well, let's just look at what happens in each case. So let's say this one is the top card after the riffle shuffle. Well, what will the color of the second card have to be? Well, look, it's either going to be this card here that gets squeezed right in after that one, or this card here will be shuffled, riffle shuffled, and positioned into the second place of this shuffled packet, okay? So one thing you can say for sure is if this one's red, the second card will have to be, quote, a blue. There's no other choice, because all of these other ones do not change their position relative to the cards in each pile, right? Now let's take a look at what happens if this one happens to be riffle shuffled to the very top of the new packet that's been brought together. Well, look, what are the candidates for the second card in the new arrangement? It could be this one, or it can be this one. In either case, it has the opposite color to the very first card, okay? And so what you're going to find, in fact, let me just go ahead. In fact, maybe we'll kind of play this out for a few steps and you can see. So let's say maybe this one goes here like that. Now it's possible that this one goes next or this one. So maybe why don't we have it go right there for that next one. Well, look what's going to happen here. What's the color of the card that will have to follow it? the red here. It's going to have to be a blue. Okay, and so what I want you to focus on is focus on pairs. So this is like position 1 and 2, position 3 and 4. Okay, now for position 5, it can be either one of these. So maybe it's a blue, right? Blue there. Well, what's going to have to happen for the 6th card? It's going to be this one or this one. So it's a red, right? Okay, so let me just bring over more of a mathematical write-up. Here's a simple explanation of the consequence of Gilbreth shuffling an alternating deck of red and black cards. Okay, so just as we saw, for the first position, it can be either color. But once a card is put in that first position, let's say it's red, what we saw was the card that follows that red has to be one of 2 black cards. It has to be black, in other words. Whereas if the top card after shuffling ends up being black, then the second card will have to be red. It will have to have the opposite color. Now it's important to realize that for position 1, it's possible that the top card will be red or black. We don't know for sure. But once we know the color, we know that the second card will have to be of the opposite color to the new top card. That will be true as we go down in pairs. Okay, so when we go to position 3, as we saw in that little magnet illustration, the card in position 3 could either be red or black. Either one's possible. But once a card is set down, the next card, which would be in the 4th position, has to have the opposite color to the one in the 3rd position. And this will be true all the way down in pairs. Okay, so pairs taken from the top will have to consist of cards of opposite color. And that's actually what he takes advantage of within his performance there. Okay, so really the first Gilbreth principle, it was surprising when it was first discovered. I mean, it's still surprising. It made quite a stir at the time in 1954-55 when it was discovered, and the first, quote, card trick was published using this principle. So yeah, it had a big debut that really got the magical community excited about this new principle in mathematical card magic. But it is now well understood, and I'm hoping that you have a better idea now as to why it is the cards taken as pairs starting at the top will always have to consist of a red and black in some order. Okay, so anyway, I just wanted to kind of explain that, because really everything that he performs there is fully explained by him except for the implications of the first Gilbreth principle, which is what we've been talking about here. But that really is what makes that effect work. And perhaps there is one more thing I could explain in his video. I'm not sure if he really explains it. That if you have, here I have an alternating deck, red-black, okay? And so if we go ahead and reverse count, which is really what he did when he was counting how many are in each half, it was just a sneaky way to reverse a bunch of the cards without people realizing that you're reversing the cards as you count them. And then if you riffle shuffle these together, as we've seen here, what's going to happen is pairs of cards taken from the top, so maybe I'll just do this is equivalent to a riffle shuffle there. It's just kind of a messy feral shuffle, right? So cards taken from the top will have the property that every other card, with every pair, will consist of a card of each of the colors. So here, red, black, black, red, black, red, and so forth. And so if you realize it has that structure, when he dealt out the cards to the spectator, one for the spectator, one for himself, these are guaranteed to be of opposite color. Okay, these are opposite color, and so forth. Okay, so what this allows you to do then is you can use the information of the cards in your packet to deduce what the color of their card must be. Okay, so since ours is black, and we know that this is the kind of companion card to ours in terms of pairs taken from the top, this one would have to be red. Same thing here. If you know that's red, This one has to be black. Okay, and that's what he did, because when he spread them out, if you notice, he kind of put the cards back at the bottom of the deck here, back here, and then he was able to just, surreptitiously kind of see the color of the corresponding card and then know the color of the spectators' cards in their little pile. So anyway, so it's a clever little Gilbreth principle performance. Hopefully that answers Mary's question as to, okay, what's really driving this effect. And if you want to watch the whole effect, now you know it's on our LinkedIn groups page, and you can learn how to do the effect and share it with family and friends. I'm sure they'll be as surprised by it as most anyone would be, except maybe those who have studied a lot of card magic. They would maybe see what's going on. So anyway, so thank you for watching, and I appreciate Mary's question. And I encourage you, and any of you, to take a look at other videos on the Absolute Math Magic channel, since I'll be posting this video on YouTube generally, as well as on my LinkedIn group page. So thank you again.